Oh yeah, oh yeah. We're working our way there. So we got to talk about radicals first. If you look at 10-7, complex numbers. Yeah. Yeah. Well, imaginary complex numbers have a real part and an imaginary part. So real quick, how many people have heard of imaginary numbers besides us just talking right now? Okay. When they first came up with the idea of negative numbers, is everybody cool with the fact that negative numbers exist? Right? In fact, some of us know all too well that when you overdraft and then they take even more money that you don't have, like, oh, thanks, you just made even a more negative number. Why would you do that? So when they first came up with the idea of negative numbers, a lot of people were like, what the shit is this? This is crap. And a lot of people called them imaginary because they were like, how could that be a negative? What are you talking about? It can't be negative feet away from me. I can't make a negative side length. And you're like, well, no, there's other means of what negative means. There's other things that it means. Unfortunately, when they looked at this, what is that? You can't do it, right? It would be a number that times itself makes -1. There's no such real number. So this is, unfortunately, the name imaginary kind of stuck. They couldn't get it off fast enough. Like the negatives, they call them imaginary for a while, and then people were like, okay, we believe you. I could owe you some money. That could be negative, or negative could mean I'm going this way instead of that way. Okay, I'm with you. Right? But then this idea came along, and it just didn't catch on fast enough, and the name imaginary stuck. It's an unfortunate name. Unfortunately, some students hear that and they're like, I knew they were making this shit up. A better name for this is what's called lateral numbers. So when we get to complex numbers, I'm going to show you a little YouTube video about what they really mean. It'll blow your mind a little bit. And it blew my mind a little bit because I actually learned a couple things I didn't even know from this video I'm going to show you. Because a lot of my teachers just didn't really go in depth into what they really, really mean. I'm like, man, why didn't they get into depth? Anyway, it's enough of that shit. So we will look at stuff called imaginary numbers. Unfortunate name. So in this one, we did number 1 already, so I'm not going to do it again. Number 2, let me show you a couple ways to do this one. Or somebody tell me how you did it. What method did you like? So again?
36 times 2.
I love it. I like it. So one way is to realize that 72 is 36 times 2. And the square root of 36 is 6. Yay. Now, a lot like reducing fractions, you could not see that. You could say, well, 72 is 8 times 9. And the square root of 9 is 3. But 8 is 4 times 2. So it's just like when you reduce a fraction, don't you sometimes have to do another step because you're like, oh, shit, more goes in. I didn't see that. All right, well, more comes out here. So it'll be 3 times square root of 4 times square root of 2. Is that cool? Yeah. Square root of 4 is 2. Times 3 is 6. Same answer, thank God. Or you could do where you break it all the way down into its parts. Good Lord. So 2 times 36, 2 times 18, 2 times 9, 3 times 3, 1, 2, 1, 2. What do I have 2 of? I have 2 2's. So that means the 2 can be out here. 2 3's, that means the 3 can be out here. And the last 2, it's stuck inside. So I get 6 rad 2. Same answer, thank God. Obviously, this is the nicest way to do it, but if you don't quite see the 36 right off the bat, you got a couple other ways you can kind of break it down. How we doing there? Is that cool? Okay. Let's see. Let me make some room for this next dude. So this one the same way. I think quite a few people broke it down. However you broke it down. Now you're looking for groups of what? 2, right? It's the square root. So I see a 2 and a 2. I see 2 2's. So I could put a 2 out there. Do I see 2 of anything else? I don't see 2 of anything else, right? I got there. So there's all of those are stuck on the inside. 2 times 3 is 6 times 5 is 30. Or you could have done 4 times 30 is 120. Square root of 4 is 2. Square root of 30, I don't know. 30, of course, looks kind of big. I'm like, it must be able to know. It's got 1, 2, 1, 3, and 1, 5. It ain't got 2 and nothing. So you can't do a square root of that directly. Okay, cool. Well, square root of 80. Yeah, so you can either see that that's 16 times 5 and get 4 rad 5 right off the bat, which would be great. Or you could do it in a couple steps again, 4 times 20. And then 20 is 4 times 5. All right, so you get a couple 2s. 2 times 2 is 4. You get 4 rad 5 again. Are you guys picking a way that you like better, hopefully? Any way you do it, you should come out with this. Cool. What about this guy? For me, I see that as the square root of Larry Bird. I don't know if you know. Oh, Larry Bird, no. I'm sorry. He's a basketball player. There you go. He was number 33. Yeah, this is 3 times 11. It ain't got 2 and nothing. So it's just not simplifiable. Right? So me saying simplify x plus y. I'm done. All right. Can't do shit with that. Can't do that. I like it. I like it. So just put already simplified, or just put something to tell me, or can't do, or something. I mean, somebody's going to write can't do next to everything. You said that's me. Being honest. Oh, shit. What about number 6? Yeah, I had to put something on there just to remind you guys that sometimes you get stuck in a certain mode and you forget that some numbers you can just do. Cube root of 64 is 4. We know that. There's no extra parts to it. What about the cube root of 40? You could break that up as, 8 times 5. I love it. You want to use the number 8 because that's a cube rootable number. Cube root of 8 times the cube root of 5. Cube root of 8 is 2. Cube root of 5 is, I don't know. What about number 8? Yeah. Cube root of 27 times the cube root of 2. That's going to be the cube root of 54. Cube root of 27 is 3. Cube root of 2, I don't know. Little tiny word, too. If you start off with a cube root, make sure it's still a cube root at the end. Right? You can't transmogrify the root somehow. It's kind of neat. That word is neat, too. What about number 9? It's kind of staring you in the face. 888. So what can come out of 888? 8. Ooh, neato.
Because 8 plus 8 plus 8. You can take it together.
Say it again?
Because 8 plus 8 is 24. I knew that I could take 3 out of it, and I got 3 and 2, 96.
Okay, and then where'd you go from there?
8 and 37. And then I took the cube of 8.
Yes, okay. Or you can just go cube root of 8 times 111. The cube root of 8 is 2, and the cube root of 111 is, I don't know. But I like that, it's really neat. Yeah, so 3 definitely goes into 888. I like it. But you almost always, the way that I personally like to do this the best is to pick a number that I can do the root of and see if it goes in. Or you can just start dividing by 2, 3, 4, whatever, right? So here I'd start with 8, and sure enough, 8 goes in. So I'm golden. Now, 111, 3 goes into 111. How do I know that? 1 plus 1 plus 1 is 3. So 3 goes into anything that adds to be a multiple of 3. 3 goes into 111 how many times? 37. I like it. And 3 and 37, there's one of each of those, so it doesn't go any further. So you do have to make sure that you went as far as you can. I like that. What about the last one? Yeah, what would have to be true? I've only got 2 zeros, which means I've only got 2 10s. I would need one more 0 to be able to do this, because then I'd have 3 10s. Then I'd be able to do it. Right now I've only got 2 10s. So I got 2 2s and 2 5s. I ain't got 3 and nothing. Shit. Nothing pretty anyway. So the cube root of 100 is a number. It's just a decimal that doesn't stop. If I have a radical that it can't be simplified to have no radicals left, it's a decimal that just doesn't stop. So all of these, they have a piece that's still a radical. It's just a number that doesn't stop. So this is the better way to write it. the best way to write is the whole number. Okay, I feel like that might be enough. We didn't finish 10.3, by the way. There's more in there. This is just the thing you got to know to be able to get into that 10.3. So we'll finish that next time. I think Wednesday I'm going to have a quiz on 9.1 and 9.2. So on, through systems of three variables, right? Systems of three equations, by hand and then by matrix, right? Okay. Woohoo! So I'll remind you tomorrow, especially for the people that aren't here,